In this segment, we are going to start discussing motion. One of the topics of motion is what we call kinematics. What do we mean by kinematics? The word kinematics means motion. And when we talk about studying kinematics, we are talking about studying the actual motion. Describing how things move. Now, when we do kinematics, what differentiates kinematics from generally stating we are studying motion is that we focus on the actual motion by itself without having to worry about the causes of motion. So in kinematics, we talk about how something is moving. If it is speeding up, slowing down, staying at rest, that's what we do in kinematics. When we study motion in general, we are going to do kinematics, but then also explain why is it moving at a constant speed, or why is it moving. Why is it speeding up? Why is it slowing down? Then that's the general discussion of motion that involves talking about forces as well as describing the actual quantities of motion. So, in other words, when we mention the word kinematics, we limit ourselves to describing the motion without explaining the causes of that motion. Now, to describe motion, we need some quantities. One of the quantities we are going to use is what we call position. To be able to describe how something is moving, it's going to help to know where it is to begin with. That's where the position comes into play. And then we are going to talk about displacement. Okay, we'll get back to the definitions of each of these terms, but displacement, which is the change in position, that's a way of describing motion. Commonly, we talk about distances. Okay, we'll have to figure out what's the difference between a distance and a displacement, but that's one of the things that we use to describe motion. Another common quantity that we use is what we call speed. That's a quantity that describes how something is moving. But then there is a velocity. We are going to need to figure out what's the difference between velocity and speed, and which one should we use to give a better explanation of the motion or a better description of the motion. And then there is acceleration. Okay, we use that word in our common day language. We need to understand what does it mean in physics. How does acceleration relate to velocity or speed or position or displacement? Okay. These quantities are some of what we need to describe motion. Another important quantity is going to be time. When was the object we are describing at that particular position? Or how long did it take for a displacement to occur? Or what was the velocity at a particular time? The acceleration at a particular time? Whatever. So time is very important, and it's tied to each one of these quantities. Now, I'm going to digress a little bit and use something that's not really kinematics, but it's in the description of motion, is what we call Newton's first law of motion, or the law of inertia. We call it both ways. Now, you heard of this law many times. Usually, it was not phrased exactly the way I have it written here. Probably you heard it: an object in motion will stay in motion, an object at rest will stay at rest. Okay, and that's essentially what we have here, but with a few important qualifiers. First, a moving object will continue moving in a straight line at a constant speed. Okay, that's important. It is a straight line at a constant speed. It's not just continue moving. It will continue moving in the same direction at the same speed. And a stationary object, an object at rest, will remain stationary, will remain at rest. Now, either one of these, motion on a straight line at a constant speed or staying at rest, would change if we act on the object by an unbalanced force. The key here is an unbalanced force. If I have an object that is stationary and I apply two forces at the same time, act on it with two forces at the same time, if these two forces are balanced, it's going to remain stationary. Think about it. This is, for example, a car sitting there at rest, and you come with all of your effort, you push, and it does not move. Why doesn't it move? It's at rest and it does not move. Why doesn't it move? Because the forces acting on it are balanced. There is your push, there is friction, balance in your force, there are also other forces along the vertical. We'll get into that later on. Another example, small cart on wheels, and we have two people pushing one this way and one this way. Now, if the forces applied by these two people are equal, they are going to balance each other, and the object is going to remain at rest. The same is applicable to moving objects that are moving in a straight line at a constant speed. Now, the other thing that you need to pay close attention to this, in this case, another point that creates difficulty with students, the fact that the moving object will continue moving when we don't have an unbalanced force. Okay. What this is saying, if we pay close attention to it, you don't need a force to have an object keep on moving. An object is going to keep on moving at a constant velocity when there are no unbalanced forces acting on it. Which means an object can be moving at a constant velocity with no forces or whatsoever acting on it while it is moving at that constant velocity. It can be moving at a constant velocity when there are two or more forces acting on it that are balanced. Either case, that's all right. The key is to keep on moving on a straight line at a constant speed. It's not going to need a force to keep that motion. So in other words, its natural tendency is to keep moving in a straight line at a constant speed without the need of a force. This is a little counterintuitive. Counterintuitive because we usually, in our common day surroundings, we see objects at rest, and to get them moving, we need to exert a force. But what this law tells us once the object is moving, we don't care how it started moving. But once it is moving, if there is no unbalanced force acting on it, it will keep moving at that constant velocity. Now, again, in our common day experiences, once an object is moving, usually if we let it go, it's going to stop. Why is it going to stop? Because there are unbalanced forces acting on it, like friction, air resistance, gravity, whatever. So there are forces, there are unbalanced forces that are going to stop it. So in our common day experiences, it's going to be very difficult for us to find cases where an object is going to be free from unbalanced forces. It's going to be very difficult to find those cases. Now, out in the universe, out in space, for example, we don't have that issue. You can have objects move in space subject to no unbalanced forces. Or we can experimentally set up cases where we have unbalanced forces. Okay, now the key again, a moving object will continue moving in a straight line at a constant speed, and a stationary object will remain at rest unless acted on by an unbalanced force.